This is a demo of relating quantities and reasoning with equations for linear equations, and this is the first workspace modeling with rates of change. When I look at the problem, it says Steve cleans the bird cages at an animal shelter. He only needs to clean the cages of birds that have been at the shelter more than a day. Steve doesn't know how many birds are already at the shelter this morning, but 3 adorable newcomer birds were adopted today. Each bird has been at the shelter at least a day, has its own cage, which takes Steve 3 minutes to clean. So I'm looking at two different variables. I'm looking at B for birds, and the time it takes to clean the cages is going to be in minutes. And because B for birds is our independent variable, minutes is going to be our dependent variable, which means we need to write an equation to determine how many minutes it takes to clean X number of birds. And we want to make sure it's in function form. So given the information in the problem, each bird takes 3 minutes to clean that bird's cage. The only birds that we don't have to clean the cage for are the 3 that arrived today. So I'm going to remove that from my B value. Question 1 says if there's 19 birds at the shelter today, including some newcomers, determine how long it will take Steve to clean the cage. So we're just substituting the 19 in for our B value, using the distributive property. So 3 times 19 gives me 57, and then minus 3 times 3 is 9. So I've determined it will take 48 minutes to clean the bird cages. If there are 15 birds at the shelter, I do the same thing. Substitute that 15 in for my value of B. Distributive property. And solve 45 minus 9 gives me 36 minutes total. The questions in this workspace all follow the same format. So here's a second example. Cheyenne works part-time at a souvenir shop where she earns $8 an hour. She normally works a 2-hour shift. However, the shop is going to be very busy over the summer for tourism, so Cheyenne's boss is going to extend her shift. So she works $8 per hour. So our variables are the amount of time that's worked and the total amount earned. So my hours I can represent with the variable H. Dollars can be D, it can be X, whatever you want to use. Normally she works $8 for every hour, but we're not counting that initial 2-hour shift. We're going to remove that so that we only calculate what she earns above and beyond her normal shift. So that equation is going to look like 8 times X minus 2, or 2 plus H. We're talking about the hours plus the 2 additional hour shift. So question 1 says, if she wants to buy a video game that's $64, how many hours would she have to add to her shift? So we're going to start with that 64, set it equal to my equation. My apologies for the view. I'm going to divide by 8 on both sides. So I get 8 is equal to 2 plus H, subtract 2, and I get 6 is equal to H. Question number 2 has Cheyenne looking to earn $88 during her shift. So how many hours would that take? Again, inverse operations, divide by 8. 11 is equal to 2 plus H, so subtract 2 from both sides, and I get 9 hours.